Hello students, welcome to the model number 3. So second of thermodynamics. So continuation of this previous slide. So that is a heat pump we are going to discuss and refrigerator. Okay. So what is mean by refrigerator? What is mean by refrigerator? That is a device which working in a cyclic delivers heat from low temperature to high temperature region, and the performance of the refrigerator we can express in terms of COP, that is coefficient of performance. See, so suppose if you want to cool the object, for example if you take any apple or any, for example you take apple, I want to make it cool from atmosphere temperature to below the atmosphere temperature. So how it is going to be cooled while in the refrigerator? Okay, in the refrigerator cabin, if I kept apple, so whatever the evaporator which is a refrigerant which is flowing through the evaporator, so that will be continuously extract the heat from the apple. So what all the heat is going to be taken away from the apple, so that apple gets cooled. So similarly, all the objects which are going to cool the object, so it will be continuous extraction of the heat from the object. Okay, so here but it is not possible by itself, so we have to give some energy input to perform this work. So main heart of this refrigerator is compressor. So we are concentrating on compressor work, so we have to invest some energy on it for the compressor. Okay, so what done on the compressor, there is input we have to give in terms of electric power. So this is the schematic representation. So there are heat source, thermal reservoirs are there. One is high temperature source and also some high temperature sink. Okay, so where this cooling space is there, continuous heat is going to be extracted, and your work is going to be done on the system, that is refrigerator, and then it is remaining heat is going to be leave to the atmosphere. So this COP of the refrigerant is we are going to define as the desired effect divided by work input. So what is the desired effect here in this case? That is heat extracted at low temperature. What is the heat extracted from low temperature is Q2, and what is the work input? That is refrigeration work, that is Q1 minus Q2. So this is about the refrigerator work, how it is going to be converted. So it is exactly reverse of the heat engine. Okay. Next, the heat pump. The concept of heat pump is the device which working on cycle which delivers heat from low temperature region to high temperature region. So the efficiency of the pump is expressed also in terms of COP. So you may know that where we are going to use this heat such kind of device is where there is a cold weather. So like European countries, they are using heat pumps because we have to continuously extract the heat from the outside temperature to the inside. So what happen if you are continuously pumping the heat, the exit temperature, that is that the heating space will be get warm or heated. Okay, so similarly for the surrounding temperature, the heat is going to be pumped with the help of heat pump. So and then it will be delivered to the heating space. Okay, so we can express this heat pump in terms of desired effect to work input. So what is desired effect here? Heat to high temperature sink and work input. So Q1 divided by W. So Q1 upon W means Q1 minus Q2. Also we can write it as 1 plus Q2 divided by Q1 minus Q2. So you should remember that. So whenever if you defining COP of the pump, heat pump, it is a 1 plus COP of the refrigerant. So efficiency is expressed in terms of percentage, and it is always less than unity, and performance coefficient of performance of the refrigerator will be uh, always less than always it is unity, and for the heat pump it is always more than unity. So that is the very basic concept you should remember. So once you understand this heat engine, refrigerator and heat pump, we'll discuss about the further topics second half thermodynamics. Based on this concept only you will get the clarity of the heat answer, that is uh, second law of thermodynamics. So we'll discuss in the next slides for the further topic. Thank you.